Hi everyone, Evgeny is back with you today, and this is the third video, I think, about our LangGraph introduction and working with AI agents. So in today's session, we will take a look at how generic agent architectures work, and we will try to create a basic AI agent which makes decision on its own, and it's up to the agent when to finish the job. So join me and let's check together how it works. In the previous video, we checked how a router architecture looks like. And just to recap this information, we had LLM and kind of brain which makes a decision. And then based on the decision, it goes either to tools path, so some job will be performing, or it just processes the input as a standard LLM machine and finishes the process. But here's the question: what happens if instead of going to the end from the tools, we would redirect it back to the LLM, like this one? And in that case, we allow LLM, like LLM decides to the same kind of flow, right? LLM either decides to run for a tool, or it processes the textual input and finishes the job. But after the tool is finished, we are going back to LLM, and then LLM again tries to make another decision if a tool should be reused, or it's enough if we process the textual information and finishing the graph. So this is the one on the right hand side, is called generic agent architecture, and here well, the agent itself, the LLM, which is behind the agent, is responsible for processing the information and making decision when the request is fully processed. So this is in general how it works, and this also follows so-called ReAct principles, a general agent architecture. And there are a lot of materials. You can search for papers in the internet and read about that in details. But in very short, it's about three verbs. It's about acting, so it's about taking an action, and this is calling for our tool. Then it's observation, where the response of the tool goes back to the LLM, to the model. And then reasoning, when LLM analyzes the response and determines or decides what to do next. Either another tool should be called, or the same tool, or we can process the information the normal way as artificial intelligence machine and send it back to the user. So this is the key thing, what is ReAct kind of architecture approach. And let's take a look how it works in practice, because enough theory here, right? It's a bit boring probably. What we will be doing in this video, this is a kind of AI agent, stock analysis AI, it's written here, just kind of marketing. And in general, we are trying to process a system which is capable of answering these kind of questions about market, about stocks, like should I invest in Tesla stocks, how does Tesla compare to Apple, what's the stock symbol for Microsoft, etc. So giving us real advice is how we can make money on the market. And for doing that, let's think about for a moment what do we need here. And the first problem, or the first tool we would need to define, is this one. For example, should I invest in Tesla stocks, right? And in general, we don't know. Okay, Tesla is a company, that's clear, but how should I investigate the internet knowing the Tesla? We need to have a symbol, right? So we need to have a function which knows how to convert the company name to a market symbol, so we can search or do the research in the internet about this company. And for that, we are defining a new tool, lookup stock symbol. So you're providing here a company name, and it makes an API call to a server with a query. We are searching for a symbol, and we are processing it and returning back the symbol. And the important thing, again, since this is a tool, then we need to be very precise. We need to give additional hints to LLM why we need this tool, what this tool is for, right? So normally this is a function name. It's a list of parameters. We know that, okay, the parameter is company name, so probably it's a company name, right? Docstring as well is a very important part. We are providing additional hints to LLM to recognize the purpose of this function in general. And here we provide an API key. You have to put your own, but if you don't have it, I don't know how. But this works with this one as well. So if you are not providing any key, it will fail. But if you provide some bullshitty thing, it will work. I have no idea why it's like that. But anyway, this is let's search for Tesla company and see how or what it returns and gives us back. So, well, everything is fine, right? For Tesla, we have this TSLA and everything is fine. And the next function, what we need is to get some information, financial information about the company itself based on its symbol. And the more information we have, the more room we have for LLM to make our predictions to our propositions or recommendations, right? And I will be using Yahoo Finance for that. There's a library in Python which kind of connects to Yahoo Finance API and provides all this information. So it's pretty straightforward. Again, I'm not going to look into details, right? Just we make an API call under the hood and we're returning combined data dictionary, which has a lot of information. And again, let's take a look how it works. So we are sure that, again, if graph is broken, at least we know that it's not because function is not working correctly, right? Because we checked it already. Anyway, let's give it a try and see what it gets back. So for Tesla symbol, what we have here, and it takes time, right? We have pretty much information, a lot of different stuff here. I'm not going to look into details, but let's open it here as in its own window and check. We have some dividends, timing, we have closing, probably the price, the close price. The high price, low open, stock splits, volume as well. We have some additional basic information like, well, I'm not going to go through it, right? We have in company officers, people working there and taking some positions, important positions, and earning report data, etc., and even describing what Tesla is in general. So a lot of information, right, will be provided to LLM machine. But it works. If you recap what we were doing last time as our router, then we need to define tools. And this is another approach I would like to show you. So you could just enumerate the tools here and that would be enough. But you still have the opportunity to provide even more information about tools and their reasoning, like what they're doing. So it's this way, you're using tool, and this is another thing from LangChain core library, and here you define the function and then you have to define name, description. There are other parameters like for example, you can provide very specific description of all the parameters, like why do you need them, which one are those, etc. But it's a bit overcomplicated for this tutorial, I'm skipping it. And interesting thing, this one return direct is false, and this gives some hints LLM how to process the output from your function, because if your return direct is false, which this means that the output will be sent back to the agent or LLM, and then LLM decides what to do next with that. Or if you say it to true, for example, this is a very easy case, and you would like just to show the user the result of this tool, you can say it to true, and then there is no other processing, just this will be the response from the agent or from LLM. But in our case, it's false because we want the agent LLM to take care of the response, right? And we're defining two functions, so it's lookup stock symbol as we saw already, and this fetch stock data row. And we define in our toolbox, which is an array or list of two functions, and well, as previously we defined in a simple LLM based on the model, we do have OpenAPI key already, and we are binding tools. Here's our toolbox. There is no output yet, but just let's define it. And here we have a very interesting part, because if you let me to refer back, we need to define this guy, and this is our assistant or agent or LLM. It's based on LLM, it's backed up by LLM. And it's a very important thing if you take a look at that. Let me scroll down. So we define an agent's node, and the very important thing here is we have to define the proper system message. So we have to to clearly state what is expected from the LLM. So the role it should perform, the tone it should process all the requests, the way, the reason why it exists, all should be very detailed, defined here, because it's very critical thing. Like if I'm changing something here, then my agent will work differently, probably. I don't know, but look at that. I'm saying you are a professional financial assistant specializing in stock market analysis and investment strategies. And I'm highlighting that you have access to tools that you can use to help you in this job. And this is your responsibilities and the format as well. And I'm asking you to be very direct and give me direct financial advices, which is not normally the case if you're subscribed to one of these financial programs, for example. They will never give you the financial advice, but here we're asking, please do this for us, because this is something we really want to have. So we define in a node here how it looks like. It's pretty simple, right? We have an assistant, it's the same state we are passing through all the time. And then we are invoking our LLM as tools. And the first message, we have our assistant system message, which defines the way how assistant processes all the information, how it works. And then we are adding all the other messages that we have. But in reality, this will be our user request, probably, the single one. But anyway, this is the kind of general way of processing things. Okay, so now we have everything in place. Just let me recap. We have two functions. We defined the LLM, which is aware of these functions, which is called tools in LML language. We defined the assistant node, which is the core of our application or AI agent. So now we have all the components to define graph and see how it works. And let me show it you here. So it starts with the same thing as last time, right? We have a builder, it's a state graph. We are adding assistant node, which is the core, again, the brain of this whole system. And this is the function which is defined earlier. And next we define tools. And this is tool node, which takes toolbox. This is everything what we did already in the previous videos, nothing new here, right? And then we define edges, and we are going from start to our assistant node. And again, the same conditional age, which takes the it goes from assistant either to tools if it's necessary, if assistant thinks it makes sense, right? Otherwise, it goes to the end immediately. So this is the way how these conditional ages work with tool condition thing. But this is the new thing, as we discussed already. Let me again scroll up. When tools are finished, we are going back to our assistants. So we're not going to the end as previously, but we are going to the LLM, to our assistant node. And for doing that, again, let me scroll, please. It takes time. We are adding a new age, which goes from tools back to assistant. So this is our graph, and again, we can compile and see how it looks like. And this is exactly what was presented in the beginning, right? So we have start, goes to assistant, and then assistant makes a decision. It either go to tools or processes the information, textual one, from the input, from the prompt, and goes to the end providing the response. Or if it goes to the tools, then tools perform something, goes back to assistant, and then assistant again makes a decision, like should I utilize another tools or should I go to the end? So that's it. Practically, we have our architecture in place. We can test it right now. And well, I have two test cases. Let's just go through them. So what's there? We have this React graph, and this is this guy. The one is shown here. And we invoke it with a message from human being, from me. So should I invest in Tesla stocks? And this is like real life question. Like if you say, yes, I will go and buy something. If you say, no, sell it, I will sell it. I don't have anything. But anyway, let's run it and see how it works and what would be the output. And again, it takes time because, well, there are a lot of things happening under the hood now. And well, it's 7 seconds already. Well, it's financial decision, right? So what do we have here? Let's see it in text editor. There are a lot of messages, right? So let's go through and check. So this is my question: should I invest in Tesla stocks? And as a result, it understands, okay, I need to have a tool call for lookup stock symbol Tesla, and then the call happened and returned Tesla. Right, the symbol, the stock symbol for Tesla. And then it was another tool call necessary, needed, fetch stock raw data for TSLA symbol, and another real call happened, and this was the response of this call. Again, a lot of data, right? And then all this information went back to our agent, and then agent decided, okay, at this point there is no need in any tools, I can process this information on my own. And as a recommendation, as a completion, it wrote this recommendation for us. So it's a waiting, you have to wait, and there are some key insights, and well, I'm not going to read it aloud, right? It's just financial information. But overall, waiting for a more attractive price point is prudent given the current valuation and market dynamics. So it gave us real advice based on the up-to-date information get from internet. So this is how it works. Again, right? It was several cycles required for different information, and finally, when agent decided, okay, I have all the information now, I'm capable of processing it and giving my completion or output. The agent generated that and finished the work. Right. And another example, it's even more interesting because this is about comparing. So how does Tesla compare to Apple? What would be a better option to invest in, right? So what should I buy, Tesla or Apple? It's even like, I don't know what will happen, I have no idea, but let's run it and see. And again, it takes time, right? Because it's, well, maybe it's time out already. That's nonsense, right? 1 minute. Okay, anyway, it's there. It's almost 1 minute. It's interesting because normally it's around the same thing, like 10 seconds. But anyway, let's take a look at the details. So I'm opening a new window again, and how does Tesla compare to Apple? What would be a better option to invest in? And it says, okay, there is a need for, look at that, there is a need for two tool calls at the same time. So we need to call lookup stock symbol for Tesla and lookup stock symbol for Apple. And then, since it's not possible to process it in one turn, there are two message calls, lookup stock symbol here and there, and we have TSLA and Apple, right? And then there is another EI message, which a tool call, which says, okay, now you have to invoke fetch stock raw data for Tesla, and the same function should be also triggered for Apple. And it's interesting because look at that. I'm not sure why, but this one says APLA, but this one is AAPL. And it's still, I have no idea why this happens. This is, by the way, the big challenge, right? Because it's not something you coded, and you have to dig into that and invest why the agent behaved this way. But anyway, I think this one is correct, right? So then what happens, we have fetch stock data row for a lot of data again, and this is for, this is, wait a second. So this is for Tesla. And then there is another call for fetching raw data. And this is for, well, it's so long list. This is for Apple. All right, and then again, the agent thinks, okay, now I have all the data necessary to making my prognosis or to generate the output. And here we have invest in Apple as a recommendation and key insights why the agent thinks Apple is better for investing in the moment. So it's market performance. I'm not going to think about that at all, right? Just financial health, it's some information, dividend and return, analyze the recommendation. And next steps. So for potential investors, look to buy Apple, and for current Tesla holders, consider taking profits. That was it for today, and I hope you found it interesting, and now you understand better what this generic agent architecture is, and you understand some drawbacks it can introduce. Like, for example, even in this short session we had it already, right? Because it wasn't clear. The function gave us the different symbol, the wrong one, but anyway, the next step, the correct symbol was used, and we even don't know how this happened, right? So this is the big challenge with AI agents. It's not something you hard code, and this is not something that is guaranteed. So you have to find your ways how you debug, how you check that your AI agents produce the result. In any way, even that not guaranteed that it will be 100% what you need. So it's really challenging and interesting work like building AI agents. But it was me, Evgeny. We will see each other in the next video about LangGraph introduction. See you.